The world is continuous.
Exploring the beauty of science.
What is earthquake? Earthquake is a term used to describe both sudden slip on a fault and the resulting ground shaking and radiated seismic energy caused by the slip or by volcanic or magmatic activity or other sudden stress changes in the earth. So how about the seismogram? Seismogram is a record written by a seismograph in a response to ground motions produced by an earthquake, explosions, or other ground motion sources. There are several different kinds of seismic waves and they all move in different waves. The first type is body waves, with subcategories of P waves or primary waves and S wave or secondary waves. The second type is the surface waves with subcategories of Ligue waves and Rayleigh waves. Let us talk the first type of wave, which is the body waves. Traveling through the interior of the earth, body waves arrive before the surface waves emitted by an earthquake. These waves are of a higher frequency than surface waves. The first kind of body wave is the P wave or primary wave. This is the fastest kind of seismic wave and consequently the first to arrive at a seismic station. The P wave can move through solid rock and fluids like water or the liquid layers of the earth. It pushes and pulls the rock it moves through just like sound waves push and pull the air. Sometimes animals can hear the P waves of an earthquake. Dogs, for instance, commonly begin barking hysterically just before an earthquake hits, or more specifically, before the surface waves arrive. This is the illustration how the P wave moves. The S wave or secondary wave, which the second wave you feel in an earthquake. An S wave is slower than a P wave and can only move through solid rock, not through any liquid medium. It is the property of S wave that led seismologists to conclude the Earth's outer core is a liquid. S wave move rock particles up and down or side to side perpendicular to the direction that the wave is traveling in, or the direction of wave propagation. This is the illustration how the S wave moves. Let us discuss the second type of waves, which is the surface waves. Surface waves travels only through the crust. It has a lower frequency than body waves and are easily distinguished on a seismogram as a result. Though they arrive after body waves, it is the surface waves that are almost entirely responsible for the damage and destruction associated with earthquake. The first kind of surface wave is called a lava wave, named after A.E.H. Love, a British mathematician who worked out the mathematical model for this kind of wave in 1911. It's the fastest surface wave and moves the ground from side to side. Confined to the surface of a crust, lava waves produce entirely horizontal motion. This is the illustration how the lava waves move. The other kind of surface wave is the Rayleigh wave, named from John William Strutt Lord Rayleigh, who mathematically predicted the existence of this kind wave in 1885. A Rayleigh wave rolls along the ground just like a wave rolls across a lake or an ocean. Because it rolls, it moves the ground up and down and side to side in the same direction that the wave is moving. Most of the shaking felt from an earthquake is due to the Rayleigh wave, which can be much larger than the other waves. This is the illustration how the Rayleigh waves move. The basic earthquake terms. The hypocenter. It is the point within the earth where an earthquake rupture starts. Epicenter. It is the point on the earth's surface vertically above the hypocenter. The focal depth refers to the depth of an earthquake hypocenter. The fault plane. It is the flat surface along which there is slip during an earthquake. While the magnitude is a number that characterizes the relative size of an earthquake. There are four basic types of fault. First is the strike-slip faults, are vertical fractures where the blocks have mostly moved horizontally. If the block opposite an observer looking across the fault moves to the right, the sleepy style is termed right lateral. If the block moves to the left, the motion is termed left lateral. Deep sleep faults are inclined fractures where the blocks have mostly shifted vertically. If the rock mass above an inclined fault moves down, the fault is termed normal. Whereas if the rock above the fault moves up, the fault is termed reverse or thrust. Oblique sleep faults. Oblique sleep faulting suggests both deep sleep faulting and strike sleep faulting. It is caused by a combination of shearing and tension or compressional forces. For example is left lateral normal fault.